Hey guys, I'm Josh.
I'm JP. Alright, today we're doing lab 4. This is part 1 of lab 4, which is the MAF sensor part of the lab. Now, this is a 2006 Toyota Corolla with the 1Z ZFE 4-cylinder engine. And we're going to identify the operation and the voltage outputs to the PCM from the signal wire. And in this case, it's an analog, so we'll be taking a look at voltage. If it were digital, we'd be taking a look at hertz.
Hey everybody. So right now we're looking at the mass airflow sensor. It is an analog. Sometimes it comes in digital as well. It also has a built-in IAT, which stands for intake air temperature as well. Okay, now starting from the mass airflow sensor, here's a diagram for it. Black is the ground wire. 3, the green wire, is the signal wire. 2 is the 5-volt voltage supply wire. And the other 2 are IAT wires. So right about now we have the key off, engine off. Now we're going to put the key on, engine off. As you see that we have almost close to 0 volts, which means it's in range. Now I'm going to start the vehicle. We have 1.6 volts. Now once we goose the throttle, it goes 3 volts.
Alright, right now key is on, engine is off, and our MAF is reading 0.5 grams per second. When we turn it on, you'll see that value go up. Upon startup, it shoots up to about 3, and as it starts to idle out, it'll go down just slightly. When he gooses the throttle, you saw that it shot up to about 75 grams per second. Right now it goes back down to about 2.7, 2.6 at idle. We're gonna simulate a short to ground right now from the signal wire to the ground that we have connected on the multimeter. And in this case, it shuts off the engine. This is a MAF only car, so the engine has no other way of measuring the air coming into it. Shuts off the engine. Now we're going to simulate what would happen if the MAF was completely disconnected from the vehicle. No signal from the MAF at all. As you saw, disconnecting the connector from the MAF actually shut the engine off. It struggled for a second, but then it completely shut off, knowing that it has no way to measure air coming into the intake manifold and to create an air-fuel mixture. So as you can see, we have technically 2 pending and 2 current codes, P0102 and P0113. Both say something with the MAF. We have mass airflow circuit low and IAT circuit high input. And the reason why we have that IAT again is because the IAT is built into the MAF sensor, and the circuit low is because it's showing no response at all, no feedback, no signal from the MAF.
When we talk about the MAP sensor, it is a precision diagnostic tool that monitors internal engine pressure to calculate real-time engine load. The data allows the vehicle's computer to optimize fuel injection and ignition timing for maximum efficiency and performance by maintaining the consistent feedback loop. The sensor ensures that the engine operates smoothly while minimizing fuel consumption and emissions. For where is the MAP sensor on the engine bay? It's on the left side of the engine or on the back. Here it is right here. It has 3 pins as well. Signal, ground, and supply voltage.
Here's a cross section of the MAP sensor connector. Right here, we have violet brown. That terminal is the MAP signal. Terminal 2, dark blue and dark green. That's the sensor ground. And the last terminal is yellow and pink, and that's your 5-volt supply. All right, here's our wiring diagram for our powertrain management on all data. As you can see right here, it says that the MAP is located on the right rear of the engine, as showed earlier. Our yellow and pink is still our 5-volt engine sensor. We have dark blue and dark green. That's the sensor return, or our ground. and then the violet and brown is the sensor signal.
All right, now we are back probing to the signal wire, and as you can see, we're reading 4.45 volts at key on, engine off. And now we're gonna turn the key on, engine on as well, and the voltage should drop. As you can see, that we have 1.3 volts, which is, it means it's in range.
Okay, so as you can see with key on, engine running, the DVOM is still back probed into the signal wire of the MAP sensor, and it's sitting at about, it'll probably go down to about 1.1 volts. It's matching the same as the PID of the MAP voltage on the scan tool. So there it is, that's at 1.1. Our MAP vacuum, that is different than MAP pressure. So this car will only send out a PID of MAP vacuum, and it's in inches of mercury. It's measuring 21. If we were to floor the throttle like right now, you saw that it shot straight down to 0, and because it's still trying to suck in right as the throttle closes shut, it shoots in a little bit above, but then it goes back to about 20 inches, 21 inches of mercury.
And another note, now that it's back plugged up, we're going to disconnect it again. I'm going to try to control the vacuum with my fingers. And if I close it completely, it cuts off.